Imagine everything you thought you knew about the universe, about space, about time, even the smallest speck of dust. Imagine all of it was well, just a tiny piece of a much grander, truly mind-bending puzzle.
Mm-hmm.
And I don't just mean grander in scale, like, more galaxies or bigger black holes,
Right.
but grander in a way that completely turns our very concept of up and down or big and small on its head.
Yeah, fundamentally flips it.
It's a vision of reality that makes the deepest reaches of space seem incredibly close and maybe the smallest particle unimaginably vast. It's about finding infinity not just out there, but right in here.
Exactly. For centuries, humanity has gazed outwards, hasn't it, at the stars, pondering other worlds, other universes.
The classic sci-fi setup.
Precisely. And our imaginations, they typically place them billions of light years away, maybe nestled in distant galaxies, or perhaps hidden in these abstract, unreachable dimensions that exist parallel to our own.
Somewhere else entirely.
But what if that next universe isn't across some unbridgeable cosmic void? What if it's not residing in some abstract dimension we can only theorize about? What if it's right here? Hidden within the very fabric of our immediate reality, woven into the subatomic particles that make up your hand, your chair, the air you're breathing right now.
Okay, let's unpack this because that's a huge idea. Today, we're taking a deep dive into a truly radical new vision of the cosmos. It's called the Embedded Multiverse Theory.
Mm-hmm.
And it's a concept that doesn't just say the multiverse is out there, a distant, perhaps forever inaccessible realm, but profoundly in here.
Right. Existing at scales we consider infinitesimally small.
It feels like a complete game changer for how we might perceive our place in the universe, really transforming our understanding of what fundamental even means.
It absolutely does. This theory challenges our fundamental understanding of scale, of existence itself. It presents something that is both elegantly simple in its core premise.
Simple.
Well, the core idea is simple, even if the implications are staggering. But it's also profoundly counterintuitive, at least at first glance. It asks us to suspend our conventional notions of size and time.
Which is hard to do.
It is. It invites us into this truly recursive, almost fractal model of reality, where every point might be a cosmos, and every cosmos might just be a point in something larger. It's an intellectual journey, really, that forces us to re-examine the very bedrock of our perceived reality.
Okay, so we have some source material for this deep dive. We've been handed this fascinating report, actually titled The Embedded Multiverse Theory. And it seems explicitly prepared for public understanding.
Which is helpful.
Very helpful. It lays out this incredibly ambitious idea in a way that makes it accessible, even as it completely stretches the bounds of our imagination. So, our mission today is to extract the most important nuggets of knowledge, the key insights from this incredible concept.
Kind of a shortcut for everyone listening.
Exactly. A shortcut to being well-informed on a topic that could completely redefine reality. It's about more than just knowing what the theory says. It's trying to grasp the truly mind-bending implications.
And our goal is indeed to break down this imaginative thought experiment.
Yep.
We want to help you grasp not just what it suggests, but maybe why it's considered so compelling, so profound.
But even if it's still theoretical.
Oh, absolutely. Even though it currently remains firmly within the realm of theoretical physics and, let's be honest, philosophical speculation, and that's a really important caveat, its implications are just vast. It forces us to consider the very nature of existence.
So it's about understanding the underlying ideas.
Right. Appreciating the intellectual journey it invites us on, and perhaps even, igniting a sense of wonder about the hidden depths of the universe that might be right beneath our noses. Literally.
Okay, let's get into it. Section 1, redefining the multiverse, the in-here revolution. So when most of us hear multiverses, our minds instantly conjure up images from science fiction, don't they?
Almost automatically, yeah.
We picture distant parallel worlds, maybe alternate timelines where, I don't know, dinosaurs still roam or something.
Or where you made a different choice this morning.
Exactly. Or these vast separate dimensions that we could never hope to access. We think of universes maybe born from quantum fluctuations in some cosmic void, or gigantic bubble universes expanding far, far away from our own.
Each forever isolated.
Yeah, that's the common trope, isn't it? The multiverse out there. It's this grand, sweeping canvas of infinite possibilities, but it always feels just beyond our reach, like a conceptual vastness stretching into the unknown, almost a separate, untouchable realm.
Precisely.
Yeah.
And the embedded multiverse theory fundamentally shifts this perspective. It takes that ingrained image of distant, unreachable universes and basically turns it inside out.
Inside out? How so?
Well, instead of imagining other universes as remote or separate, maybe separated by unimaginable cosmic distances or these weird metaphysical barriers, it proposes they are all around us, hidden within the very building blocks of our reality.
Within particles?
Potentially, yes. The core idea is brilliantly simple, yet, as you said, mind-bending. The multiverse isn't out there, far off in some distant realm. It's profoundly in here, woven into the very fabric of our immediate existence.
That really demands a significant conceptual leap, doesn't it? Moving from an external, distant multiverse to one that is internal, intimately interwoven with our own perceived reality.
It really does. It profoundly challenges our intuitive sense of space and proximity. We're used to thinking of small as, well, less complex, right? Simpler.
Yeah, the building blocks.
But what if small is merely a matter of perspective, an arbitrary boundary we've drawn based on our own scale? The philosophical implications of such a localized multiverse are just staggering.
Staggering how? What does it really mean?
It means that every atom, every subatomic particle, maybe even every speck of what we consider empty space around us could potentially be teeming with entire self-contained universes.
Teeming, like full universes inside an atom.
Each potentially operating under its own unique rules, maybe its own physical laws, and certainly at its own unique pace. It transforms our immediate environment into something infinitely more complex and profound than we could ever have imagined. It forces us to reconsider the true density and the hidden richness of existence.
The report offers a fantastic analogy for this, a really visual one to help grasp it. Thinking of reality like a set of Russian nesting dolls.
Ah, yes, the Matryoshka dolls.
Exactly. You know, those beautifully crafted wooden dolls, each one a perfect miniature version of the last, fitting snugly inside. You open the big one, there's a smaller one, open that, another smaller one.
And so on, potentially infinitely.
Right. It's an elegant way to conceptualize these layers of existence, a beautiful illustration of recursion.
And that analogy is crucial, really, for grasping the core concept of the embedded multiverse theory. In this view, our universe, the one we inhabit, with its billions of galaxies, its vast cosmic web, all the dark matter and dark energy we're still trying to figure out.
Or a doll.
Our doll, exactly. It's a complete self-contained entity, with its own laws of physics, its own stars and planets, its own cosmic history, from the Big Bang to whatever its eventual fate may be.
Okay, makes sense so far.
But the astounding part, the really radical part, is what the theory suggests lies within this doll. If we could hypothetically zoom in on what we perceive as a single fundamental particle within our universe.
Like an electron or a quark.
Precisely. An electron or a neutrino or even a quark. We might discover another complete universe nested inside it.
Wow.
And that universe, in turn, could contain its own particles, each potentially housing another universe, and so on and so on.
Infinitely.
Potentially, yes, infinitely nested.
So hang on, an electron whizzing around my coffee cup right now, or an atom in the air I'm breathing, could literally contain a whole cosmos, with its own stars, its own galaxies. That's almost impossible to picture.
It is incredibly hard to visualize, I agree. The picture it paints is one of infinite nesting, this fractal cascade of realities within realities. And it forces you to ask, what would it truly mean if what we see as infinitely small a point particle, something maybe dimensionless in our physics, is actually infinitely vast from its own internal perspective?
It completely breaks our definition of fundamental, doesn't it?
Absolutely. If what we consider to be the irreducible building blocks of matter are themselves complete self-contained universes, then our whole quest for the smallest particle becomes, well, it becomes an endless journey into an ever-expanding interiority. It's not about finding the bottom. It's about understanding the layers.
So maybe every atom in my body, every pixel on this screen right now, every single photon of light hitting my eyes could contain entire worlds, entire cosmic histories unfolding inside them.
That's the implication. It suggests the universe isn't just vast in its outward expansion, which we already struggle to comprehend, but it's also unfathomably dense and infinitely complex in its inward structure.
So what we think of as empty space between particles, or even the particles themselves, they aren't empty at all.
According to this theory, no. They're potentially gateways to entirely distinct and thriving cosmoses, each a universe unto itself. It's a dizzying thought, truly. The sheer density of reality implied here is, well, it's enormous.
Okay, this is already bending my brain. Let's move into section 2. Decoding the key principles of this embedded multiverse theory. Where does it get really interesting?
Well, here's where it gets really interesting, because, as you hinted, this isn't just pulling ideas out of thin air. This theory actually builds upon some of the most profound discoveries in modern physics.
Like Einstein.
Exactly. We all know Einstein blew up our fixed classical notions of time and space, didn't he? Showing us that time isn't absolute, it can slow down or speed up relative to an observer, or that gravity isn't just a force, but a warping of space-time itself.
Right, relativity, time dilation, length contraction, all that strange stuff at high speeds or near massive objects.
Precisely. This first principle of the embedded multiverse theory takes that established understanding of relativity and essentially extrapolates it to an extreme, almost unimaginable degree.
Cranks it up to 11, you said earlier.
Yes, exactly. For a universe existing inside one of our particles, the theory proposes that the scales of time and size will be so incredibly different from our own, so radically compressed or expanded from our perspective, that they would be almost incomprehensible to us.
How different are we talking?
Well, this is the truly astonishing part. The theory proposes that for a universe existing inside one of our particles, get this, 1 billion years could pass.
1 billion years.
In the time it takes us to blink.
Wait, a blink? Like a fraction of a second for us is 1 billion years for them.
That's the core idea. Imagine that. Their entire cosmic history, from their own equivalent of a Big Bang through epochs of stellar formation, maybe the rise and fall of complex civilizations, all the way to their final heat death or maybe a big crunch, all of it could happen in less than a nanosecond of our time.
So their entire cosmic story, everything that ever was or will be for them, just flashes by in an instant for us. That's not just fast forwarding, that's almost beyond comprehension.
It really is.
So how does that make direct observation virtually impossible for us? It's not just about them being tiny, it's this time difference too.
It's far more than just speed or size, yes. The profound implications of such extreme temporal and spatial relativity mean that direct observation isn't just difficult, it's fundamentally impossible with our current understanding and technology.
Why fundamentally?
Because we simply don't operate on a timescale that could ever perceive such rapid, transient cosmic events. Our instruments, our very perception of time itself, are far too coarse. What's an eon for them? An entire geological age could be less than the shortest measurable Planck time for us.
The absolute smallest meaningful unit of time in our universe.
Exactly. So there's no way for us to see it unfold. It completely challenges our anthropocentric view of cosmic time, of evolutionary scales. It suggests that our understanding of progress or duration or complexity developing over time is utterly relative to our own scale.
So what we perceive as instantaneous, like a quantum flicker or a particle decaying that could be an entire eternity, a full-fledged cosmic saga for another reality hidden inside?
That's the implication. It's like trying to watch a movie of an entire universe's history, but the entire movie plays out faster than a single frame of our movie. Makes you wonder, doesn't it, about the transient nature of our own existence from some hypothetical higher perspective. Perhaps we are but a fleeting moment for some larger external observer.
That's unsettling and fascinating all at once. Okay, let's talk about the second principle. You mentioned particles as seeds. In our everyday understanding, reinforced by particle physics, we see particles as these tiny, simple points of energy, right? The basic building blocks.
The fundamental Legos, as you put it earlier.
Yeah. We smash them together in huge machines like the Large Hadron Collider. We study their charges, their spins, their interactions, always trying to find smaller and smaller constituents. We think of them as the end of the line, fundamentally.
That's the standard model view, yes. But this theory suggests they are much, much more than mere building blocks or points of energy.
More how?
According to this second principle, each particle isn't just a point or a quantum fluctuation. It could literally be the seed for a whole cosmos.
A seed, like an acorn holds an oak tree.
In a way, yes, but on an infinitely grander scale. This means a complete universe, potentially with its own unique physical laws, maybe different strengths for gravity or electromagnetism, different fundamental constants, maybe even entirely different types of elementary particles than the ones we know.
Wow, so not even necessarily obeying our physics.
Potentially not. It could have its own galaxies forming from its own cosmic dust, its own stars igniting, perhaps even its own unique forms of life, all contained within what we perceive as a single, tiny, subatomic entity.
So you're saying within a quark or an electron, there could be a universe where gravity works completely differently, or light travels at another speed entirely. That just opens up an incredible, almost infinite range of possibilities.
It really does. The variety could be endless.
But again, How would we ever know? If they're operating on that blink and you miss an eon time scale, and they're inside something already too small to see properly, they'd be completely invisible to us, wouldn't they?
Absolutely. And that's crucial here. These embedded universes would be so incredibly small from our perspective and operate so blindingly fast relative to us, as we just discussed with the relativity principle, that they would be completely beyond our perception, effectively invisible.
So our most powerful electron microscopes, our most sensitive particle detectors.
They would only register a particle. They'd see its charge, its mass, its spin, maybe its decay products. They would never be able to resolve the galaxies or the potential civilizations contained within. It's a difference in scale and time so vast, it creates an unbridgeable observational gap.
This completely transforms the concept of fundamental particles in our universe then, doesn't it?
Radically. If what we consider fundamental is actually a universe in itself, then the very idea of fundamental becomes recursive. It becomes a relative term, not an absolute endpoint.
So we might never find a bottom to reality. Just more layers.
That's what it suggests, an infinite series of fundamentals nested within each other. It shifts the very goal of particle physics, perhaps, from finding the ultimate smallest thing to understanding the layers and the intricate connections between these vastly different scales.
That opens up truly staggering possibilities, just the sheer variety of potential existences hidden within what we consider empty space, or the quantum foam they talk about at the subatomic level.
Exactly. Every single point in space could be infinitely rich with hidden realities, each following its own unique cosmic path, maybe governed by laws we can only begin to imagine. The universe suddenly becomes infinitely denser with potential.
Okay. Principle 3, this one tackles quantum mechanics, right? The weirdness at the smallest scales.
That's right.
Scientists have been baffled for decades. I mean, truly baffled by the strained, almost inexplicable behavior of particles at the quantum level. It's famous for being weird.
Infamously weird, yes.
We're talking about quantum mechanics, where things just don't behave like predictable billiard balls or planets orbiting a star. Particles seem to, flicker in and out of existence?
Or exist in multiple states at once as probabilities until measured.
Right. They change their properties randomly. They seem to collapse from this wave of possibilities into a single definite point only when we observe them. It defies our classical logic. It's profoundly weird. And it's one of the greatest mysteries in physics, the infamous measurement problem being a prime example.
It absolutely is. And this is precisely where the embedded multiverse theory offers a truly, poetic, I suppose, and certainly imaginative explanation for some of this quantum weirdness. It tries to bridge that gap between the infinitely small behavior we observe and the infinitely grand scale of a cosmos.
How does it explain the jumpiness?
It suggests that when we observe a particle seemingly jump, or instantaneously change its state, what looks like a sudden, maybe uncaused shift in its properties, or wave function collapsing, we might actually be witnessing something far more profound than just a simple subatomic interaction.
More profound how?
Well, the stunning suggestion here, tying back to the relativity principle, is that what we see as an instantaneous change, a fleeting quantum event, that could actually be the entire lifespan of an embedded universe.
The entire lifespan?
Yes. Its birth, perhaps its own Big Bang equivalent, its expansion, the whole evolution of its stars and galaxies, the potential flourishing and fading of life within it, its eventual contraction or heat death, all of it.
All of that cosmic drama appears to us from our vastly different timescale as just a single fleeting event, a momentary flicker in the quantum realm.
That's the hypothesis.
Yeah.
A quantum jump isn't just a particle changing its energy level. It's potentially the end of one contained universe and maybe the beginning of another, or just the entire cycle playing out in an instant from our view.
That almost makes you feel bad for smashing atoms and particle accelerators. Are we inadvertently, collapsing entire civilizations every time we make a measurement?
It's a humorous, yet also quite profound thought, isn't it? It really highlights the scale difference. But yes, this theory attempts to reconcile the seemingly bizarre, random nature of quantum mechanics with a grander cosmic narrative.
So it reframes quantum weirdness.
Exactly. It reframes our understanding of what's truly happening at the subatomic level, potentially transforming what appears to be random quantum fluctuations into the unfolding destinies of entire cosmosis. It implies an unfathomable vastness and complexity contained within the smallest observed phenomena.
It offers a new, deeply imaginative lens through which to view one of physics' greatest and most persistent mysteries. It suggests there might be a hidden order, a hidden meaning within the apparent chaos.
Precisely. Giving profound cosmic significance to every quantum event, suggesting that the universe isn't just strange, but perhaps infinitely active and generative on scales we can barely conceive.
Okay, and the fourth principle takes this even further. This idea isn't a singular event, right? Not just our universe containing smaller ones, it's recursive.
That's the key. Recursion.
It suggests the pattern of universes within universes, and potentially our universe, being within a larger one, can repeat endlessly, up and down the scale, like cosmic fractals stretching into infinity in both directions. There's no ultimate bottom, maybe no ultimate top.
That's exactly right. If a particle in our universe can, according to this theory, contain another universe, then the logic extends upwards too. It stands to reason that our own universe, our entire observable cosmos, might simply be a fleeting particle, a tiny excitation in a much larger, grander reality.
So we could be the quantum fluctuation.
We could, quite literally, be a quantum fluctuation in the metaphorical laboratory of some giant, higher-level being or system, a momentary blip in their existence, much like the embedded universes are presumed to be to us. This chain of nested realities could extend infinitely in both directions. Smaller universes within particles within our universe, and our universe itself being a particle within a larger structure, which is within a larger one. It creates this infinitely nested fractal tapestry of existence.
A never-ending Russian doll.
Exactly. It paints a picture of reality where there's no ultimate bottom level, no smallest fundamental constituent, and perhaps no ultimate top level either. Just an endless progression of scales, each containing and being contained by others.
That gives a really dizzying new meaning to macrocosm and microcosm, doesn't it? They're no longer just poetic analogies in this view.
Not at all. They become potentially literal descriptions of the universe's structure.
But what does this do to our sense of cosmic significance? Or insignificance? Are we just infinitesimally small and meaningless? Or is there a strange kind of grandeur in being part of such an infinite, intricate structure?
You've hit on the core philosophical tension, haven't you? It certainly transforms macrocosm and microcosm from mere analogies into potentially literal descriptors, and what it means for our significance. Well, it's both incredibly humbling and potentially exhilarating.
How so?
On one hand, yes, we are simultaneously infinitesimally small in the grand chain of nesting, perhaps a mere speck within a particle, almost vanishingly irrelevant on the grandest scales.
That's the humbling part.
But on the other hand, there's a kind of grandeur. We are part of this infinite structure, and potentially our own universe contains infinite complexity within it. We're a link in an infinite chain. It echoes some very ancient philosophical and mystical ideas, doesn't it?
Like what?
Ideas about the self-similar nature of the universe, where patterns observed at one scale are reflected at others. Think of Hermetic principles like as above, so below, or certain Eastern philosophies that speak of Indra's net, this vast air-connected web where every jewel reflects every other jewel.
So this theory gives those old ideas a potential, maybe unintentional scientific framework.
It gives them a potential grounding in modern theoretical physics, yes. It suggests reality is this never-ending discovery, a boundless journey of exploration, no matter which scale you're observing, looking outwards to the galaxies or inwards to the particles. It turns the cosmos into this endless Russian doll, each layer revealing new depths, constantly inviting us to expand our understanding of what reality truly is.
Okay, it's a fascinating picture, but let's talk about why people find it compelling. Section 3, the allure of the theory. Even though, as we've stressed, this is a profound thought experiment, it's not yet directly provable with our current instruments.
Right, we can't just crack open an electron and peek inside.
Exactly. So why is it considered so compelling, so captivating by those who think about these big, grand ideas? What is it about this particular vision that grabs the imagination so powerfully beyond just its speculative nature?
That's a fantastic question, and it's important. The report we looked at outlines 3 key reasons that really speak to its deep appeal, both scientifically and, maybe just as importantly, philosophically. It seems to set it apart from many other theoretical constructs.
It resonates.
It does. It's not just imaginative. It resonates on several profound levels that seem to speak to the human desire for understanding, for meaning, for order in the cosmos.
Okay, the first reason the report highlights is its elegance. Now, we hear that word a lot in physics and math, don't we? Theories are often praised for their beauty, their simplicity. But what does elegance truly mean in the context of a cosmic model like this? It's more than just being pretty, right?
Oh, far more. When physicists or mathematicians talk about elegance in a theory, they usually mean its ability to explain a great deal with a minimum of assumptions or postulates. It implies an internal consistency, a symmetry, and yes, an aesthetic appeal that often derives from that very simplicity and power.
So how is the embedded multiverse elegant?
Well, the theory provides a remarkably neat, sort of self-contained picture of reality. It proposes this fundamental mirroring, where the largest scales and the smallest scales beautifully reflect and echo each other through this nesting principle. There's a profound sense of completeness and self-reference to it.
Like a cosmic fractal pattern.
Exactly, like a fractal pattern that repeats, potentially infinitely. This inherent simplicity and balance, this cosmic symmetry, it seems to appeal deeply to the human desire for order, for pattern recognition in the universe. We like finding underlying principles.
It suggests the same rule applies everywhere.
Right. It suggests that the same fundamental principle of existence nesting or containment applies universally, creating a harmonious and unified structure across all scales, rather than, say, a chaotic patchwork of unrelated phenomena at different levels. It's beautiful in its recursive logic. It offers a kind of satisfying intellectual closure, even if the implications themselves are mind-bogglingly wide open.
In physics, an elegant theory often feels right, because it brings seemingly disparate things together under one simple overarching rule. And this theory seems to do that across scales in a unique way.
That's a great way to put it. That's the essence of its elegance.
Okay, the second reason for its allure, according to the report, is that it's somehow intuitive. Now, that might sound counterintuitive itself for something so incredibly mind-bending.
Right, it seems paradoxical.
But the report explicitly says it taps into an ancient, almost primal human idea. As above, so below. How can something so radical, so physics-heavy, also feel so familiar?
That's precisely right, and it's a really powerful point of resonance, I think. This theory, despite its modern theoretical physics trappings, genuinely taps into a very old and pervasive human intuition.
The microcosm reflecting the macrocosm.
Exactly. The concept of as above, so below. The idea that the patterns of the cosmos are somehow reflected in the smallest parts of nature, that the microcosm mirrors the macrocosm. This has been a cornerstone of philosophical traditions, mystical paths, even spiritual beliefs for millennia across countless cultures.
You mentioned Hermetic philosophy earlier.
Yes, Hermetic philosophy, alchemical texts that saw connections between the planets and metals, ancient Eastern cosmology like Ingo's net we talked about, describing universes as these vast, interconnected nets where every part reflects the whole. This idea has permeated human thought for a very long time.
And this theory gives a literal physical interpretation to that.
It gives a potential literal physical interpretation to that age-old wisdom, yes. It connects with a deep human desire to find universal truths, to find connections, to see unity in the apparent diversity of the world. So it feels familiar on some subconscious, maybe archetypal level, even if its specific application here, entire universe is packed inside particles, is radically new and pushes the absolute boundaries of our understanding.
So it feels inherently right somehow, even if it's astounding.
It seems to for many people. It provides a sense of cosmic coherence, a feeling that things fit together in a meaningful way, which is something many people seek when contemplating the universe.
Okay, and finally, the third reason. The report states that it addresses a truly colossal question that physicists and philosophers have been grappling with for decades, especially since multiverse ideas became more mainstream in physics. That question is, if there is a multiverse, if other universes exist, where exactly are they? Many theories propose their existence, but they often leave the location kind of vague or abstract or just forever beyond our reach.
Indeed. And this is a critical point of its appeal, I think.
Yeah.
While many other multiverse theories are intellectually compelling, whether they propose parallel dimensions branching off at quantum choices, or giant bubble universes forming from cosmic inflation, or higher dimensional brains,
They often feel very disconnected from us.
they often place these other universes in abstract, unreachable spaces, or in parallel dimensions that exist conceptually but seem beyond any possible physical interaction, maybe even beyond tangible conceptualization from our vantage point. We can't point to where they are.
But this theory gives them an address.
In a conceptual sense, yes. The intellectual satisfaction of the embedded multiverse theory is that it provides a concrete, even if currently unprovable, location for the multiverse. It places it not in some distant abstract space or an inaccessible parallel dimension, but quite literally within the very structure of matter. The matter that we interact with, that makes us up every single day.
So again, every electron in your body, every atom in the chair you're sitting on, every photon of light hitting your eyes right now, all of them potentially contain other universes.
That's the idea.
That brings the infinite conceptually within reach, doesn't it? It makes the multiverse not just some theoretical construct floating out there, but a potentially inherent feature of our immediate reality. It's a very different, much more intimate answer to the where question.
Exactly. It answers the where in a way that is profoundly compelling. It feels immediately relevant, even if mind-boggling. It gives the concept of a multiverse a tangible, albeit microscopic and temporally compressed, address.
This tangibility, even if it's purely conceptual for now,
It offers a sense of grounding that many other theories lack. It transforms the abstract into something deeply intimate, suggesting that the universe's greatest secrets aren't just out there in the cosmic void, billions of light years away, but might be hidden in plain sight, woven into the very fabric of our everyday existence. It's a truly humbling and simultaneously exhilarating thought.
Okay, let's try to wrap this up. We've truly taken a deep dive today into an idea that absolutely stretches the imagination, challenges our most basic preconceived notions, the embedded multiverse theory.
It really does push boundaries.
It's a vision where universes are not just distant concepts, relegated to the farthest reaches of space or these abstract mathematical dimensions, but potentially hidden, nested within the very fabric of our existence.
Right here.
Making our daily reality potentially infinitely more complex, more dynamic, and more astounding than we could possibly comprehend.
And this theory, it profoundly challenges us, doesn't it, to reconsider the fundamental nature of reality itself, to redefine the meaning of scale, what is truly big, what is truly small. Are those even absolute concepts anymore?
I mean, they're just relative.
Exactly. And in doing so, it forces us to reevaluate our own place within the cosmos. Our very small place on one level, yet potentially vastly significant place on another as part of this infinite chain. It's a perspective that's both humbling and exhilarating, suggesting that even the most seemingly inert piece of matter could be teeming with cosmic drama.
It paints this picture of existence not as linear or flat or even just three-dimensional in the way we normally think, but as an infinite fractal tapestry, constantly unfolding, constantly nested within itself.
A universe made of universes, contained within still larger ones, potentially stretching on forever in every direction, both inward and outward. It's recursion made manifest as reality.
Think about that for a moment as you listen. Entire worlds with their own unique cosmic destinies, their own laws of physics, perhaps even flourishing and fading life, could literally rise and fall with every flicker of energy, every quantum event happening constantly within our universe.
It suggests an unfathomable depth and dynamism to what we perceive as empty space, or the seemingly inert building blocks of matter. It utterly transforms the mundane into the potentially miraculous, offering a sense of boundless activity, boundless creation and destruction happening at every conceivable scale, all the time.
Now, while we may never be able to directly prove something like this with our current scientific tools, perhaps the very act of trying to observe an embedded universe would, by its quantum nature, disrupt or destroy it.
That's a fascinating possibility in itself, yeah. The observer effect taken to the ultimate extreme.
Right. But even without proof.
The embedded multiverse theory serves as this incredibly powerful reminder, doesn't it? A reminder that reality might be far stranger, far more complex, and indeed infinitely more wonderful than we can possibly imagine.
It really leaves you wondering, doesn't it? What else might be happening all around us right now? What other realities, what other phenomena are we simply too large or perhaps too slow or just operating on such a radically different scale to even perceive? Happening in every breath you take, in every atom that makes up your very being. What else is hidden in plain sight?